Hi guys, Mr. O'Brien here. I'm going to give you guys a video today all about how to balance chemical equations. This is going to be super important. You're all going to need to be able to do this for your everyday chemical reactions project. Quick warning, this video is a little bit longer than some of the other ones, but that's because, like I said, it's got a lot of information that you're going to need. If you feel like you're getting saturated and you need to take a break, press pause, go get a drink of water, come back, watch the end of it, okay? If you miss something, rewind it and watch it again. But like I said, this should be a valuable resource for you as you crack into your individual topics for the ECR project. In order to demonstrate how to balance chemical equations, I'm going to start off by actually doing a chemical reaction for you, okay? So that we can see a reaction take place, and then we're going to take a look at how we can represent what's going on an atomic level through one of those chemical equations that you've been reading about, okay? I'm going to do a reaction today with two ingredients. And remember, in chemistry we call ingredients reactants. It's what we're starting with. So I have two reactants. They're both ionic compounds. And the first one is called calcium chloride. Okay, so I'm just going to put this right here for a minute. And like I just said, this is an ionic compound. So hopefully you remember, ionic compounds form between metals, okay, on this side of our staircase, and nonmetals, okay, elements on this side of our staircase. So calcium chloride, we've got some calcium here, that's a metal, and it's bonding with chlorine, a nonmetal, okay. Calcium, it's in that second group on the periodic table, which means it has two valence electrons it's trying to get rid of. Meanwhile, chlorine has 7 valence electrons. It's one of those halogens. It can only accept one of the 2 valence electrons that calcium is trying to get rid of. So in order to get rid of both of those valence electrons, we're going to need 2 of these chlorine atoms, one for each of those valence electrons, because like I said, these guys, they only have room for one more each. So I'm not sure if you can see on my bottle here, but we've got the chemical formula listed right underneath the name of the compound, and you'll see, just like I said, CaCl2, because there's going to be 2 chlorine atoms for every 1 calcium atom present in this compound. Okay, the next reactant that I'm going to be working with is something called sodium hydroxide. This is another ionic compound, okay? I've got sodium here, that's a metal. It's in my first group, so it has 1 valence electron that it's trying to get rid of. And that will form our cation. And the anion in this compound is called hydroxide. Some of you might be thinking, hydroxide? I don't remember hearing of an element called hydroxide on the periodic table. And that's because hydroxide, even though it's an anion, it's actually not an element. It's actually made up of 1 oxygen atom and 1 hydrogen atom. And so since this negative ion is made up of more than 1 type of element and more than 1 atom, we call it a polyatomic ion. Poly means many, so we've got more than 1 atom here making up this anion. Okay. All right, I'm going to go ahead and change the camera angle a little bit so that you guys can see exactly what's happening as we go through this chemical reaction. Hold on just 1 second for me. Okay. All right, so when we write a chemical equation, we're going to put our reactants, okay, what we're starting with on the left-hand side, right? Here in the United States, we read left to right, and so it makes sense that we put our starting stuff over here on the left, okay? So those 2 ionic compounds I was just talking about, I've taken them already and I've dissolved them into water, okay? So this is my calcium chloride dissolved in a solution of water. All right, I'm going to just go ahead and write the name of that compound right underneath it here. Okay. Ca. And like I said, we need 2 chlorine atoms there. Okay, so that's our first reactant. Okay. The second reactant that I just brought up was called sodium Na hydroxide, OH. Okay. And we're going to add these things together as we perform our chemical reaction. Now, you guys probably noticed in the first part of this video that I'm wearing gloves right now. I'm also wearing eye protection. That's because this is actually some pretty nasty stuff. This is what we call a strong base. And so I'm sure you guys have seen in like comic books and stuff like that when someone gets acid on their skin and it burns them. Well, bases are kind of like the opposite of acids, but they can actually be just as corrosive. They can burn your skin really, really badly. In fact, some people have used this stuff to try to like dispose of bodies after a murder to try to kind of cover up the evidence. This is called lye in non-scientific terms, and you do not want to get this stuff on your skin. It'll give you a really bad chemical burn. Okay, so I've got my two reactants, calcium chloride and sodium hydroxide. Okay, and I'm going to combine those for you now so that you can see the chemical reaction take place. Okay, so I've got a test tube here, okay, and this is what I'm going to use to combine these two reactants. Okay, so I'm going to put a little bit of my calcium chloride in. Okay, add just a tad too much. Okay, and rather than using a funnel for my sodium hydroxide, because like I said, this stuff is pretty nasty. I want to be really careful that I don't spill any of this. So I'm going to use a dropper on this because it's a little bit safer that way. Okay, so I'm going to just take a pinch from this dropper here, okay, and I'm going to add it to this test tube, okay? And I want you guys, as this reaction takes place, to look for evidence of a chemical reaction. So take a look. Think, is there a new gas being produced? Is a precipitate or a solid forming? Is there a release of light or heat? Okay, so think about what are those pieces of evidence to know whether or not a chemical reaction is taking place. Okay, all right, I'm gonna just add a couple drops here and see if you can see that. Let me get nice and close to my camera. Okay, so some of you may be thinking, oh, Mr. O'Brien, that's a color change. I remember color changes, that's a good piece of evidence, okay? But be careful, look closely, use those observational skills. Is this really changing colors right now? If you look, it's kind of hard to tell in the video, okay, but it's not actually a color change that's occurring. What's happening is we're forming a solid here. Okay, we're forming a solid. That's again what we call a precipitate, and then that solid is kind of sinking down, finding its way to the bottom of that test tube. So the formation of this precipitate, that's one of those really good pieces of evidence that a chemical reaction is taking place. Okay, let me set this aside for a minute because now I want to show you guys exactly how we're going to balance this equation. All right. This reaction is a type of reaction, and we're going to go over these different types of reactions next week. But this is called a double replacement reaction, okay? Because essentially what's going to happen with these two substances is my cations, my calcium and my sodium, are going to switch places, okay? So they're just going to kind of trade partners. Right now, my sodium is happy with my hydroxide anion. My calcium's happy with my chlorine anions or my chloride anions, and they're just going to change partners. Okay, so what's going to happen is I'm going to end up over on this side of my products, what it was just produced in that test tube. I'm going to end up with some calcium hydroxide, okay, and I'm going to end up with some sodium chloride, okay. Now, a couple things, okay? You may recall this calcium had a charge of +2 on it, okay? That's why it was bonded to 2 chlorine atoms, each with a -1, okay? this hydroxide ion, okay, that had a -1. That's why it was bonding with just this one sodium atom with a +1 charge. Okay, now I've got a calcium that has a +2 charge bonded with a hydroxide ion with a -1 charge. So I'm actually going to need 2 of these things. So I'm going to put this whole thing in parentheses because this kind of acts like a unit. And I'm going to need 2 of them. Okay. You guys aren't going to need to know all of that. You're probably in your research going to find a chemical reaction. And what you're going to need to do is you're going to need to balance it. Okay. Balancing chemical equations, that's a result of the fact that when we do a chemical reaction, we're not creating any new atoms and we're not destroying any old atoms. All of the atoms that I started with over here are still going to exist over here. This is similar to that law of conservation of energy that we learned back, way in, I think it was August, the first thing we talked about at the beginning of the year. Remember, energy can't be created nor destroyed. It can only be transferred or converted. Well, same thing here with atoms, okay? We can't destroy them. We can't create them. We can just change kind of who they're bonded to, who their partners are. Okay, so the key to balancing equations is we want to make sure that we're starting with the same number of atoms for each element on this side as we're ending up with over here, okay? We can't change the subscripts on these, okay? Because that has to do with the charges like we were just talking about, right? For every calcium atom, we're going to need 2 chlorine atoms. So we can't change that, okay? If we do that, we're changing what this substance is to begin with, all right? We would have a completely different reactant here, and we don't want to do that. We want to keep this as is. So what I'm going to do is I'm just going to look at my reactants right now, and I'm going to list over on this side just how many of each of these different elements that I have right now. So let's start off with calcium. Okay, so I've got some calcium. All right, how many atoms of calcium do I have right now? Well, there's no subscript here or anything like that. So we know there's just 1 calcium atom here. Okay, the next element that I have present is chlorine. Okay. Oh, I've got some subscript here. I've got a 2. That's telling me that in this compound here, I've got 2 chlorine atoms. Okay, so over on this side in my reactants, I've got 1 calcium atom, 2 chlorine atoms. I've also got 1 sodium atom. I've got 1 oxygen atom. And I've got 1 hydrogen atom. All right. Now, this should be, like I said, the same number of atoms for each element over on the left-hand side that I have over here on my right-hand side. Okay, so let's go ahead and do a quick inventory on this side and see how many of each atom that I've got. Okay, calcium, it's got no subscript or anything like that, so I've got 1 atom of calcium. Okay. Next, I had a chlorine. How many chlorine atoms do I have over here? Looks like it's just the 1 in this sodium chloride. Okay. Next up, we've got sodium. Okay, how many sodium atoms do I have in my products? Well, it looks like it's just the 1 here. Okay. How many oxygen atoms do I have? Okay, look. Now I've got oxygen in these parentheses. And look, I've got a subscript of 2. Now this 2 is referring to everything inside these parentheses. I have to distribute the 2 to both of these elements. This 2 is telling me that I've got 2 oxygen atoms and 2 hydrogen atoms here, because this 2, again, is referring to everything within these parentheses. Okay, so I've got 2 oxygen atoms. And like we just said, that 2 isn't just referring to my oxygen, it's also referring to my hydrogen. So I've got 2 hydrogen atoms as well. Okay. Does it look like I've got the same number of each element on my reactants and my products? Doesn't look like it, okay? Over here I've got 2 chlorine atoms. Here I've got 1 chlorine atom. Here I've got one oxygen atom. Here I've got two oxygen atoms. Okay, so what happened here? Did we just pull some extra oxygen atoms and some extra hydrogen atoms just out of thin air? No, we can't do that, okay? So that means if I've got two oxygen and two hydrogen atoms over here in my products, I must have had two oxygen atoms and two hydrogen atoms over here in my reactants, okay? But I can't just add subscripts on here and say, oh, done. Because if I do that, I'm changing the very substance that I started with. So we can't just do that, okay? This whole thing, this is like a package together, right? My sodium is bonded to my hydroxide, okay? So what I can do is I can say, rather than just adding individual atoms, I could add another sodium hydroxide compound, okay? So this is what we call a coefficient. This is a large number that goes right in front of the compound and says, look, I've got two of these compounds, two sodium hydroxide compounds. Okay, so this 2 means now that I've got two sodium atoms, two oxygen atoms, two hydrogen atoms, because I've got two sodium hydroxides. Okay, so if I just added a 2 over here, okay, now I'm saying I'm going to need two sodium hydroxide atoms. That's going to change the numbers of each element that I've got over here now, okay? So before I was saying I was starting with one sodium, but no, I've got two sodium hydroxides. So this is going to change to a 2, okay? This 2 says I've got two oxygen atoms now. And this 2 says I've got two hydrogen atoms now. All right, now we're getting a little bit closer. We got the same number of oxygen atoms. We've got the same number of hydrogen atoms, same number of calcium atoms, but look at this here. Here we've got a problem. I'm saying I've got two chlorines in my reactants and two sodiums in my reactants, but over here I've only got one chlorine and one sodium atom in my products. So just like we did over here, we can say, look, if I start with one calcium chloride, two sodium hydroxides, what is that going to produce? Okay, what is that going to make in the end? Well, it's going to make one calcium hydroxide, but it's actually going to make two sodium chlorides. Okay, so I can say, you know, this isn't going to make one sodium chloride. It's going to make two. And again, this 2 is referring to everything, okay, that comes after it here. All right, so two sodium atoms and two chlorine atoms. All right, let me get rid of these arrows. All right, how are we doing now? Okay, this looks pretty good, okay? We've got one calcium atom in our reactants and one in our products, two chlorine atoms in our reactants and two in our products, two sodium atoms in our reactants and two in our products, two oxygen atoms in our reactants, two in our products, two hydrogens in our reactants, and two in our products, okay? So what this means is we've got the same number of atoms for each element that we started with and the same number of atoms for each element that we end with. No atoms were created, no atoms were destroyed. We just broke the bonds that were holding these two substances together, rearranged them to create two new substances, okay? So if we go back and we take a look at that test tube that we just did our reaction in, okay? We started with those two solutions and we made something new. So there's still water in here. I didn't include that in this reaction because we weren't breaking apart any water molecules in the process. So we've got some water here. And then down here in our precipitate, we've made some calcium hydroxide and we've made some good old-fashioned sodium chloride table salt. Okay, so I'm not going to drink this. That would not be good for my health. But I suspect that if I did, it would be very salty because I've got the presence of that sodium chloride. So again, just to kind of summarize for you guys here. when we are balancing chemical equations, okay, write out the equation with your reactants and your products, okay? You can't change the subscripts here. Don't mess around with these little numbers that are kind of hanging down here, right? We're not allowed to mess around with those because if we do, we're changing the very reactants and products in the chemical reaction, and we've got an entirely new animal here, okay? So leave these subscripts alone. Don't mess with them, all right? But these coefficients, these big numbers that start right before a compound that tell you how many of each molecule or compound that you've got here, okay? You can change those because think about it. I mean, how many molecules of calcium chloride was I starting with here? Well, probably millions and millions of them. So when we do a chemical reaction or an equation like this that we're trying to balance, I'm not asking you exactly how many molecules of each substance you're starting with. What we're trying to figure out is the ratio, okay? How many calcium chlorides to how many sodium hydroxides do I need? So essentially this means that for every calcium chloride compound that I used, I needed 2 sodium hydroxide compounds in order to produce 1 calcium hydroxide and 2 sodium chlorides. And again, this is because we're not creating any new atoms, we're not destroying any old atoms. All right, guys, thanks for your patience. Again, if any of this seemed a little confusing, take your time, press pause, go back, rewind, rewatch a section of it. And as always, you can reach out to me or Mr. Stoll by email or contact us during our office hours. All right, guys, great job. Thanks a lot.